To determine if this block needs to go in machine shop, we're going to measure that number 2 cylinder right there. And we're going to use a dial bore gauge. So looks like this guy. Okay, so now before we measure our cylinder bores, we're going to have to set up our dial bore gauge. Now to set this gauge, you have to have the gauge, obviously, but you also have to have a mic. And the reason being, we have no clue what this distance is. As you see, I can move it all over the place. However, we know that this distance is now set to our bore of 3.900. So we're going to set this gauge in here, and we're going to depress our little pintle until it goes into the gauge, which is going to make our dial move, and I'll show you that here in a second. And we're going to go back to math class here. Shortest distance between 2 points is a straight line. So when we put this in here, not only do we have to find the shortest distance, up and down, but also in and out. And that'll make it to where we're perfectly straight across through there, and then our gauge will be set. So now we're going to set our gauge back in here, and we're going to get it to read the smallest measurement. The smallest measurement is going to be on the negative side. So we're going to set it in here and rock it back and forth until we find the lowest measurement. Looks like we're about 7/10,000ths off right now. So pull the gauge out since it's really sensitive, and we're going to turn this dial. That's how we set our 0 point, and we're going to turn it backwards 7/1000ths. It's going to put me about right there on the 5 on my needle. Stick it back in here and double check it. And we're maybe still about 1,000th off, or 10,000th off rather. So I think I went the right direction there. Yeah. So they were pretty close. Close enough for government work anyway. Okay. So now that that's zeroed out, we're now ready to go measure the bores in the block. We're going to measure that number 2 cylinder right there. And what we're going to do is we're going to come in here, go down about 1/2 inch. And then what we're going to do on the gauge is we're going to try to find the lowest number possible. Which on this one is about 14/10,000. Actually, no, I'm reading that wrong. It's about 16/10,000ths of an inch. And then we're going to go down about halfway into the bore, and we'll check it again. Once again, we're trying to find the lowest measurement. So it's about 13/10,000ths. And then we'll go towards the bottom of the bore, and we'll check it again. And about 8 or 9/10,000ths. So that means that bore has a taper of about 6/10,000ths of an inch. That's pretty good. Now to check the out of round, you do the same thing. You just turn the gauge sideways. See, on this one, we start out at about 5/10,000ths. Still about 5-ish. About 5 at the bottom. So what that tells me is if I was to do the math on this cylinder here, since everything down across through here
was pretty much 5. You can imagine that this side of the bore is perfectly straight up and down. And this one was tapered in a V shape. Now we start off at like 14 10 thousandths, and we go down to about 9. So it's about, well, that's about 10 thousandths, which is pretty much nothing in the world of engines. But if I wanted to find my out of round, since this was 5 10 thousandths, this was 14, you're about 9 10 thousandths out of round. There again, that is nothing. So this bore is pretty round. And when we go to put our new piston in here, the manual wants you to install the piston straight down. Which, since we have a new piston and an old bore, the manual calls for a 6 thousandths feeler gauge. And what they want you to do is slide this gauge down in beside of the piston like this. And then use a spring scale to pull the feeler gauge. And I should have 5 to 10 pounds of pull. Now it's kind of hard to show on camera, but I already did it on this cylinder. And it pulled about 13 pounds. But as all these cylinders wear over time, they lose a crosshatch and get a polish on them. So what you want to do is get you a cylinder horn like this one. And you're going to put a crosshatch in there to deglaze that cylinder to give the ring something to seat to. Now of course when you do this, you're obviously enlarging the hole. You're taking material away. So you want just enough to make a crosshatch and to kind of deglaze. Once you get that step done, you need to go back to the feeler gauge. You don't want to take off too much, because if you lose that 5 to 10 pounds pull, you're going to have to get a different piston or bore the block. Or in the case of this block, bore it, maybe sleeve it. So we don't want to do that. You can kind of see the glaze down in there. And I just want to remove that. You can kind of see a little crosshatch action going on, but not too much. But we just want to remove that. Now, when you go to hone these, I recommend taking some WD-40 or some transmission fluid, whatever you got handy. Just kind of spray a cylinder just a little bit, act a little bit of a lubricant. And we're going to stick this down in here. We're going to spin the drill and then just go up and down with it. Okay. So now we'll take a clean towel. I'll put it down and see what our hatch or what a cylinder looks like. Let's see here. Okay, so it honed it pretty nicely, but I don't really have a good cross hatch. So usually your cross hatch, if you go really quick up and down, is where you get that. So just be sure you get that cross hatch. That'll help your ring seat, and it helps to hold oil, which helps to build your compression. one more wipe down here. Okay. See, now we can see our cross hatching. Versus this cylinder, which I know there's dirt in it, I haven't cleaned it yet. But there's your before and your after. So it's a little top heavy on this, I know of. So hopefully I honed it correctly. I might have to get a little further down in it. But now I'm going to take my piston and I'm going to invert it and then stick it down in there about 1/2 inch from the edge of the skirt. And then I'm going to stick that 6/1000 feeler gauge in there, and I'm going to see what kind of pound pulls on it. And hopefully I'm in the 5 to 10 pound pull range. Okay, now no, the camera didn't magically go crooked. I've turned the block sideways. And the reason for that, this piston is smaller than that bore. And so whenever I go to pull this, if I don't have something down there to catch that piston, it's going to fall on the floor, break, bend, who knows what. It's just not a good scenario. So I got it sideways just to kind of help me hold it a little bit better. So we stick the piston down about 1/2 inch and stick our feeler gauge down in there and try to get it as far as you can. Okay. We'll take our scale and then we'll pull it. And I didn't really catch what that went at. I think it was around 10. I know it hit 8 and I took my eye off of it like a dummy. So let me reset it and try it again. And one thing to note, my wrist pin's forward and backwards as if the piston was in the motor, and my feeler gauge is 90 degrees to that. And you want to try to pull as straight as you can. That one looked like it come out at about 8. So that's how you can tell if you need to go to the machine shop. You check your board taper and you're out of round. And I'll put the specs at the bottom of the video so you know what they are. They're in the service manual. I would highly recommend you get one. But this bore is now ready to have a piston ring put in it and have the end checked, because these are file fit rings. Once we get the piston rings file fit, we'll get them on the piston and it'll be ready to install the piston. But now I have to go and do these other bores. And if you're wondering why I did this bore instead of number 1 first, this bore actually had the worst taper at 15 10/1000ths. The rest of them were right at 1/1000th of an inch. So I did this one first to make sure I didn't need to go to the machine shop, because no use for me to do it whenever they got better equipment. Okay, so we got the bore honed out. It's within spec. Our taper's nice. Our out around is nice. So now it's time to start fitting our piston rings. I got a set of Cleveite rings for this thing. I'm not sure what the number is because it's got another sticker off of it, but I can find that for you and let you know. Of course, these are diesel rings, not gas motor rings. Now, they should be a file fit ring. However, I just did the number 1 cylinder and I didn't have to touch a single one of them. Be careful with these because you have 5 rings total. Number 4 and 5 are in their own separate bag. Now number 4, which is the oil scraper ring, you pretty much don't have to check it, but I would check the other 4. Now the Cleveite rings came with a piece of paper that said you want a minimum of 4 thousandths of an end gap, which is right here, per 1 inch of bore. Well, since we pretty much have a 4-inch bore, you know, or 3.9, so call it 4. The minimum that I would say is 16 thousandths of an inch gap. The manual is calling for 10 to 20. So I would probably go with the ring manufacturer. And what I actually have is I have my feeler gauges set to 16 and 21. And the reason I have 21 versus 20, if I make the 16 go, 21 doesn't go, then I'm somewhere between 16 and 20 thousandths. So I'm in spec. Now the way that I do these, and this is the 5th ring down on the piston, the very bottom one. And there's no markings for a top or bottom. But you're going to set the ring down into the bore. Then we're going to take our piston and set it on top of the ring and use it to push it down in the bore. And I'm pushing it until this is flush with the block. That way it's roughly halfway down the bore, and since I use the piston to square it, I know I'm squaring the bore. So now I'm going to take my filler gauge, which I know y'all can't see this up there, which I'll show you one of them eventually. Probably turn it sideways so you can see it. Well, I'm going to take my 16 first. Okay, my 16 slides in. It's nice and tight, but it slides in. So I can already tell you that that 21 is not going to fit since the 16 was tight. And with that being the case, this ring is good. So I'm going to take this ring and just set it back on the number 5 bag versus putting it on the piston, since I'm using the piston to square my ring up in the bore. This is ring number 3, because like I say, number 4s are oil scraper ring. You don't really have to do anything with them. Now, the rings 1, 2, and 3 have a little dot on them right there. That dot needs to face up when you install them, and just go ahead and do it while you're gapping them as well, just so you know everything's good. So, same process. We'll get it started. Use our piston to push it down flush. Same scenario. Make the 16 fit and the 21 not. That ring there is also good. Pull it off, set it back on number 3. So, number 2 has a dot. Something I haven't mentioned, where you put the gap in the bore for this doesn't really matter that much, since our bores are pretty circular and we're still within a 4 thousandths range, so it probably doesn't affect it anyway. Back to flush. 16's good. 21's good. And our number 1 ring has a little dot on it right there. Nice and flush. 16 fits. 21 does not. So, just like my number 1 cylinder, my number 2 cylinder does not need any filing of the rings. Now, if you have to file the rings, the best way to do it is a ring file end gap filer. It's basically a machine you stick in there. It's got like a cutoff wheel disc and you spin it. Now, out of all the motors I've built, I've had to file fit a couple of rings, and to me it's not worth buying that tool. I'll probably get flack for this, but I'd literally just take a die grinder with a little sanding disc on it, like a little air grinder, and I'll just lightly sit here and tap this thing, try to keep it as square as possible, because most of them you're just taking off a few thousandths, so it's not that difficult. And when you do that, you just grind it, stick it back in there, and double check it until you get your gap. But these are all good. So now to put them onto the piston. Okay, now just for illustrative purposes to show you what I'm doing further down in the bore. This is the number 5 ring for the number 4 cylinder. Right here is the end gap. Now what I'm doing is taking the 16 thousandths feeler gauge. See how it goes into it? That's what I want. Then I take the 21 and it doesn't go in. So that's what I'm doing further down in the cylinder. Alright, so to put these piston rings on, I'm going to recommend that you get a ring expander tool of some sort. Typically I don't use these. However, these rings are pretty stiff and you're having to send them a long way down this piston. So they do help. Now the first one I'm going to put on, I'm actually going to do from the bottom, which was our number 5 ring. I'm basically going to just take it, I'm just going to kind of spread it a little bit over the skirts, slip it down, and then just slide it until it snaps into the groove. Now, the 3-piece oil rings. The way that I install these is they're, split just like everything else. This ring here, the top and the bottom of the ring will actually rest on a little lip on either side right here. Sometimes you have to put like one of these and then this guy and then this guy, but this design, this guy goes first. You just have to look at it and see how your rings are. When I put these guys on, what I typically do is, since I have 3 rings in one groove, I try to put the end gaps 120 degrees apart, basically where my fingers are right now. And that just makes the oil have a longer route to try to get out and into the combustion chamber, for blow-by issues and oil consumption issues. These are so small, you can actually just spiral them down on, and I actually recommend it. Because if you try to use the installer, they'll just go all whoppy jaw on you and be a pain in the butt. So there's the first ring on top of the spreader ring, or scraper ring, whatever. So I have a gap, or an end gap right here. And the other one's right here. So I have a gap here and a gap here. So I want my other one over here somewhere. And this is kind of the only ring that I try to install in the correct location at the moment, because the other ones, when you're looping them up, they'll spin around and stuff. So your gaps on your other ones, don't worry about lining them up until you get ready to actually put the piston down into the block. So there's that ring installed, and the other one, of course. So now we'll start with ring number 3. And remember, our dot goes towards the top of the piston. So about the easiest way to do these guys is just kind of set it up here on top and just gradually open it up until it starts to fall down onto the piston. And then you're just going to walk it down to the 3rd groove and get it into the 3rd groove. And always just, make sure they're nice and loose. That way they're not bound up, and I know I got it in the groove. Okay, 2nd ring, dot towards the top. Same thing as the 3rd one. Set it on top, barely expand it to get it to start to go over. And then just walk it down to the 2nd groove. And of course, same procedure for the top ring. And there's our dot. Let's see. And there we go. There's all of our rings installed. So now this piston is ready to be installed onto the rod. And one more thing. I have not touched any of these rings, as far as file fitting them, since these two have been great. However, if you have to file fit your rings, which I recommend doing this anyway, once you actually start putting your rings into your bore, go ahead and mark what piston or what bore this piston's going to go into. That way I know that this one will go here, then number 1 will here, 3 and 4. So same thing was whenever I honed this block and actually did the pull gauge. 1, 2, 3, 4. Always keep them where they go. Same thing with the rods.